later on you'll see the value, okay? So to write a bit more about this, okay, in FCC, what we tend to observe is relatively weak, i.e., it is easy to deform, right, and have usually better ductility, okay? Usually, okay? So example of elements with FCC structures, they are like your copper, they are like your aluminum, right? They are like your silver, gold, and also your platinum. All the expensive material, right? So now you understand why gold is easy to deform. Pure gold. I'm not talking about those with impurities. Okay, pure gold's easy to deform. Silver is the same. Copper is the same. Easy to deform with high ductility. Okay, so in general, FCC, lower force, is required to induce deformation. Okay. Okay. So the next one that we see that I would like to go is BCC. Okay. So for BCC, as you have seen, I'm going to this is how in schematics BCC look like. Okay. So if we were to pick this atom, the point of contact is now 1. Okay, I'll change color. Okay. 1, 2, 3, and what? 4. Okay. Even if you pick the center one, okay, let's say we pick the center atom. If we pick the center atom for if we were to pick the center atom, we have what? 1, 2, 3, 4 contact with the adjacent what? Atoms. Okay. In BCC, if I were to pick at the center, you have what? 1, 2, 3, 4, 5, and what? 6. Okay, physically. Okay, it's difficult to do this in atoms because we cannot see that close. We need expensive equipment. We don't have that. So you can see that also. Okay, so the adjacent atom, so on BCC now, okay, right, the adjacent atoms have more points of contact relative to FCC. Okay, so it's well known that BCC material with BCC structures has what? High strength. Okay, high strength and lower ductility when compared to FCC. Okay, so example of elements with BCC structures. Okay, so we have things like tungsten. Okay? We have things like vanadium. And we have things like chromium. Okay, they tend to have BCC structure. And then finally, we also know that high forces is required or are required to induce deformation. So for this case, if this is your start point to induce slip, you need to have a force in the X direction, and then you need to have a force in the Y direction. Whereas on FCC, you only need force is what? In the Y direction. Are we clear? Okay, so this is a simple explanation. If anyone asks you, okay, any accountants ask you, can you explain to me why FCC is easier to deform than BCC? Just tell him, give me some money. Okay, so you can see how I demonstrate with what? With points. Are we clear? It's not difficult to do. Okay, don't tell him we need to rent a very powerful microscope for me to show you. Does not work like that. Okay, right. So if we go into steel, okay, if we go into steel, if we look at steel now, so if we go into steel, we know that in steel structure we have what? Austenite, or sometimes also known as retained austenite. So austenite tend to have what? FCC structure. So whenever you see any steel with high percentage of austenite in your mind, you know it's going to be easy to what? Deform. Okay. And then we tend to have what? Ferrite. And when we have ferrite, we know that it has what? BCC. And now I say BCC, what comes to your mind? Not easy to what? Deform anymore. Okay, more forces are higher. And then we have the next thing called what? Perlite. Now, perlite is a compound. So what is perlite made of, anyone? Oh, very good, very good. I'm so proud of you. Oh, I'm so happy. Gordana thought you're really well. How is Gordana? Is she really good? Right, she is like one of the best researchers around, and yet she can teach really, really well. Okay, don't worry, I won't get rid of her. I will make her work until she want to retire. Okay, but she is really, really good. Okay, I like her a lot. Okay, cementite. So we know that ferrite is what? Anyone know what is cementite? Eh? Yeah. BCC, FCC, or what are they? Anyone? So cementite are laminar plates. They are neither FCC or BCC. They are laminar plates. They are classified as ceramic. and they tend to be brittle and what? Hard. Okay. And the last one they tend to observe, commonly observe, is what? Martensite. Martensite is it has highly distorted BCC structure with limited sleep. Okay, it has limited. So whenever you see martensite, what comes to your mind? Bad news. I repeat again, when you see martensite, what comes to your mind? Bad news. Okay, get ready for your customer to pay more money. Are we clear? Okay. Now, always remember, when a material is hard, okay, when we say the material hard is related, okay, when a material is hard is related to what? It's related to brittle. Are we clear? Okay. And cannot absorb, okay, a lot of energy during deformation. Okay. It does not have the capability to absorb what? A lot of energy. Okay. And then when a material is soft, it's related to what? Yeah, to ductile. Okay. And it is able to absorb what? A lot of energy. Now, if you hear anyone telling you that the material, this material is hard and ductile, call me. Really, I want you have to call me. Okay, if anyone, look, I've invented a material that is hard and ductile. You know what we will do? We will put a lot of money to buy the material and sell it elsewhere, or we put a lot of money into the stock of this company that make this material. But I'll tell you, it will never what? Happen. Up to today, I can't find a material that is both hard and what? Ductile. We clear? Okay, you have to get this clear. Now, if now I go back to, I can't remember now. Okay. Week number 2. First material has what? Perlite and ferrite. The next material have martensite, small percentage of written austenite, and it has what? Ferrite. The next material have martensite and ferrite. The last material have martensite, bainite, written austenite, and what? Ferrite. If you look at the microstructure, somehow you can relate it to the strain hardening behavior, yes or no? Right? Look at it. Okay, don't look at me. Okay, nothing to look. Right? Now, let's say now you look at SI 1045, ferrite and what? Perlite. Okay, so that is your what? Benchmark, the reference. Now you look at USIBOR now. It had martensite, small percentage, deliberately write down there, small percentage of retained austenite plus ferrite. What is martensite crystal structure? highly distorted TCC together with what? Limited what? Slit. Then you also have what?